Hi everyone. In today's class, I'll work out a numerical example to calculate the effectiveness and efficiency of a fin.
Now we'll work out a numerical example. A carbon steel with thermal conductivity 54 watts per meter degree centigrade with a cross section of an equilateral triangle. So the shape of the cross section is an equilateral triangle and having a side of 5 mm is 80 mm long. The length is 80 mm. It is attached to a plain wall which is maintained at a temperature of 400 degrees centigrade. The wall temperature is 400 degrees centigrade. The surrounding environment is at 50 degrees centigrade. Ambient temperature is 50 degrees centigrade and unit surface conductance, that is heat transfer coefficient, is 90 watts per meter square degree centigrade. Compute the heat dissipated by the rod assuming tip is insulated. Assuming that tip is insulated or neglecting the heat flow from there, this is a small area, we are neglecting the heat flow, or assuming it's insulated, you can use a reduced equation for heat transfer. Also compute the efficiency and effectiveness of the fin. We need to calculate the two parameters which I defined: efficiency and effectiveness. Now, I have written the data here. T0 is 400 degrees centigrade, T is 50 degrees centigrade, heat transfer coefficient is 90 watts per meter square degree centigrade, K is 54 watts per meter degree centigrade, L is 80 mm, you can write it as 0.08 mm. Side of the equilateral triangle is 5 mm or it's equal to 0.005 meter. Altitude of the triangle is, this is the altitude, and altitude h divided by 0.005 by 2. This is 0.005, this is 0.005 by 2 is equal to tan 60. So you get the altitude of the triangle as 0.005 by 2 tan 60. Okay. So opposite side by adjacent side is tan 60. So h is equal to 0.005 by 2 into tan 60, which will give 0.00433 meter. Now you can find out the area of this triangle, half of base into altitude or height. So half base into height, I calculate the area as 1.0825 into 10 raised to minus 5 meter square. Now we can calculate m as root of hp by KAC. H is 90 and perimeter is, it's a triangle shape. So you have to add, and this side is 0.005. 3 times the side, that is a perimeter. So 0.005 into 3, that is a perimeter. K is the thermal conductivity is given as 54. Area of cross section you have calculated, that you can substitute. You will get m as 48.057. So that is the value of m. Now you can find out the heat transfer Q as KACM theta 0 tan HML. This formula I used since it is given that heat flow from the end is neglected or end insulated. So K is 54 into the area of cross section we have calculated, that I have substituted, and M is also calculated as 48.057 into theta 0 is 400 minus 50. That is the temperature difference at the root. Plate temperature is 400 and ambient is at 50. So theta 0 we have calculated as 400 minus 50 into tan x. M is 48.057 into length. The substitution is made and you get the heat transfer through the fin as 9.823 watts or 9.823 joules per every second. That is the heat flowing through the fin. Now to calculate the efficiency, you can use the formula which we have derived as tan HML by ml. Tan x hyperbolic function, m is 48.057. So efficiency is tan x, m is 48.057 into length is 0.08, length of the fin, divided by ml substituted, you get it as 0.259. That means it is only 25.9% efficient. Its efficiency is low. What is the maximum efficiency? 100%. 100% is theoretical value, but higher value is always desirable. That shows the fin is more efficient in convecting or conducting and later convecting the heat. So for the heat transfer to be efficient, then you should get a higher efficiency. Now we will find out the effectiveness of a fin. Effectiveness is Km by H tan HML. So this is a reduced formula by taking fin with and insulated. So K is 54, M also we have calculated, H is known in transfer coefficient, and tan H M is 14.057. Okay, and the L is also substituted. You get the effectiveness as 28.81. So that is the effectiveness of the fin. Now, what does that 28.81 means? By providing the fin, the heat transfer has increased by times. 28.81 times. In the absence of fin, if the heat transfer is 1 watt, by providing the fin, the heat transfer will be 28.81 watts. But how about efficiency? We have seen that efficiency is low. The same fin, if the same cross section, same length, if the fin material, if you change and if you make that higher conductivity, efficiency will improve. Okay, the efficiency of conduction, transferring the heat would have improved, and you would have got a better efficiency, and also the effectiveness would have increased.